Hello, I'm Jim Kennard of Food for Everyone. I'm going to be showing you pictures from all around the world as we talk about soils today. Thanks for joining me as we learn about the vital role soils play in growing healthy vegetable crops. Good soil is essential to healthy plants. For this reason, if you want to grow healthy plants and have abundant harvests year after year, you must know the answers to 4 questions covered in this video. Number 1, what are the 2 types of soils? Number 2, what are the 5 functions of soil? Number 3, how does soil become infertile? And number 4, how can soil fertility be restored? Number 1, what are the 2 types of soil? In traditional gardening, soil is the main substance in which plants are grown. An exception, of course, is hydroponic gardening, where plants are grown in a water solution that is supplemented with nutrients. There are 2 main types of soils, organic and inorganic. Organic soils consist of plant residues which are derived from decomposed vegetation. Examples of organic soils include peat and muck, sawdust, ground bark from evergreen trees, and so forth. Organic soils are light and fluffy and a pleasure to work in, but they only rarely contain the inorganic minerals which healthy plants need for food. In contrast, inorganic soils consist of rock fragments which have broken down over time. Inorganic soils and rocks are made of the same material, but they vary in the size of their particles. It is the size of the particles that makes the many inorganic soil combinations, like sand, clay, loam, and so forth. Also, unlike organic soils, inorganic soils are often hard, and so they can be difficult to work with or dig in. Now, because inorganic soil is ground-up rocks, and since rocks contain all the essential minerals plants must have, it would follow that inorganic soils contain those essential minerals. And this was true originally. However, since the minerals in inorganic soils became depleted over time due to leaching, erosion, and crop removal, inorganic soils, like organic soils, often do not contain sufficient amounts of minerals which healthy plants need for food. So, the type of soil is not as important as the functions the soil performs for the growing plants. Number 2, what are the 5 functions of soil? Because the laws governing plant growth are the same regardless of where they are grown, good gardens of equal quality can be grown in virtually any type or combination of soil, including organic and inorganic, so long as the soil provides 5 essential functions. The soil must A, provide anchorage for plant roots, B, hold water and oxygen for plant use, C, store inorganic minerals for plants to use as food, D, act as a temperature regulator in hot weather, and E, afford drainage for plant roots. If any of these functions are not adequately provided, it will be impossible for you to grow a healthy, productive garden. For example, you can't grow a productive garden in swampland because the soil does not provide adequate drainage, so the plants suffocate from lack of oxygen. Similarly, you can't grow a productive garden in toxic soils where there is too much aluminum, boron, alkali, and so forth. However, when these 5 functions are provided, with some loving care, you can grow a good garden virtually anywhere and in any type of soil. For example, large quantities of organic material in the form of sawdust were used on Okinawa, Japan, to grow these highly productive vegetable gardens. And large amounts of sawdust yielded similar results at Loma Linda University in California. But just as impressive, are the equally productive gardens which were grown in these inorganic soils in Russia and Fiji. But too much or too little of any substance can make a soil less productive for gardening. For example, in this soil there was not enough of one particular element, namely phosphorus. And in this soil, several essential minerals were missing. In contrast, this soil had too much mineral fertilizer, which causes a condition known as salinity. And here is another example of salinity. Remember, soil is soil, whether organic or inorganic, and its influence on crop yield and quality depends not so much on the type of soil, but rather whether or not the soil provides the 5 essential functions, including the right amount of water-soluble mineral nutrients. Therefore, one main objective in gardening is to eliminate infertility and regulate fertility. Here's an important note. Organic materials added to inorganic soil will improve soil tilth or texture and water retention characteristics, but no nutritional value is received by plants until the organic materials revert back to inorganic solutions. Care must be taken not to compost plants with disease, insects, or weed seeds into the garden. Number 3, how does soil become infertile? To understand how soil becomes infertile, we need to first understand how plants use the soil for food. It may help you to think of soil as a system of storage shelves, holding the important minerals and water all plants need for food. Through the natural processes going on constantly in the soil, chemical changes are also occurring constantly. These natural processes change insoluble minerals into the water-soluble inorganic compounds which plants must have for food. These compounds must be water-soluble because they are absorbed by the plant roots growing in the soil shelves. Once inside the plants, the inorganic compounds are converted into organic compounds, which we then harvest and use for our food. On the other hand, if the soil does not store enough of these inorganic compounds, or if the compounds are not water-soluble, they cannot be used by the plants for food. So, the problem of infertile soil lies in the lack of water-soluble inorganic mineral compounds in the soil. And as we've already mentioned, since soil is made of very small particles, which can move easily from one place to another, it has naturally eroded as the result of centuries of rain, wind, snow, and crop removal. All of these factors continue to cause the small particles of water-soluble compounds in soil to move into creeks, rivers, and eventually into the oceans. As this happens, soils become less and less fertile, thus reducing the land's inventory of available minerals so essential to plant growth. Number 4, how can soil fertility be restored? The one and only solution is to reverse the process just described, which is the cause of infertility. Fortunately, erosion does not change larger rocks so quickly. So when man-made machines pulverize these larger rocks and their resulting minerals are carefully measured, packaged, and then applied to either organic or inorganic soils, they produce healthy, high-yield gardens. The secret to success in restoring soil fertility is accuracy. Too much or too little is equally bad and results in disappointment and loss. Accuracy means weighing or measuring the materials precisely and then applying them evenly to the garden soil. Plants are in this sense like people, since they require a variety of a balanced mineral formula. That is why the steps of preparing the soil and then accurately feeding the growing crops by adding supplements to the soil provides healthy, productive vegetables year after year in virtually any kind of soil all over the world. In conclusion, both organic and inorganic soils can produce equally productive gardens if they contain vital water-soluble minerals in the right amounts and they perform the other 4 essential soil functions we've discussed. Furthermore, Since soils naturally erode and become infertile over time, these nutrients must be accurately reapplied to the soil when the soil bed is being prepared and when the plants are fed. In this way, any soil can be used with equally impressive results. Thank you.